Okay, folks, looking at quite a tricky rationalizing the denominator question, okay, from an AS pure maths paper, but this is also appropriate for GCSE 9-12 maths higher tier as well, but it's taken from an AS pure maths paper, so don't worry too much here about the mark allocations, but this is grade 9 year rationalizing the denominator for GCSE 9-12 maths, GCSE further maths, or yeah, but mainly taken from the AS pure maths exam, okay, looking at rationalizing surds. Question number 4. Show that root 6 over root 3 minus 2 can be expressed in the form m root n plus n root m, where m and n are what we call whole numbers, okay? So what we call integers, okay? Whole numbers. Fully justify your answer, okay? So the key here is that we are going to multiply the numerator and denominator by the conjugate of the denominator, i.e. the denominator, but we flip the sign, okay, of the middle term, okay? So we're going to multiply top and bottom by root 3 plus 2 over root 3 plus 2, because that creates what we call dots, so difference of two squares, okay, on the denominator, hence getting rid of the surd on the bottom of our fraction, okay, on the denominator of our fraction, okay, hence why we call it obviously rationalizing, okay, so it stops us having a surd on the bottom of our fraction, okay? So now multiply fraction here, multiply top by top, bottom by bottom. So root 6 times root 3, that'll be root 18, or the square root of 18. And then root 6 times root 2, okay, becomes root 12, okay? So I can write it under 1 square root. On the bottom, okay, on the denominator, okay, here's the key. So you do this times this minus this times this, okay? So root 3 times root 3, that'll be root 9, which is going to be 3, minus 2 times 2 is, 4, okay? Root 4 is equal to 2, so we have that, okay? So that's the little cheat code, okay? Because the middle terms end up cancelling, okay? Because you end up having plus root 6 minus root 6, okay? They just end up cancelling, okay? Hence, difference of two squares. Then you have minus 2, okay? So the little trick here is that whenever you have difference of two squares, okay, multiply the first term by the first term and the last term by the second to last term, okay? So you do root 3 times root 3, which is root 9, which gives you 3, and then minus root 2 times positive root 2 is minus root 4, which simplifies to negative 2 or minus 2, okay? Because that minus stays with it. Okay, and all we do now, just to simplify, the numerator, okay, 3 minus 2 makes 1. Okay, so I can get rid of that, okay. So now I'm just left with root 18 plus root 12. Okay, I can simplify these surds. Root 18 is root 9 times root 2. Okay, again, if you check it if you're unsure. Okay, root 9 times root 2. And then root 12 is root 4 times root 3. Okay, so remember, we're looking for the biggest square number factor that goes into obviously each number here separately. Okay, so it's knowing your square numbers. Okay, root 9 is 3, so we have 3 lots of root 2. And then root 4, guys, is 2, so we have 3 root 2 plus 2 root 3. And that makes sense here because obviously m is equal to 3 here and n is equal to 2. Okay. So this just simplifies, okay, to the end of 3 root 2 plus 2 root 3, okay? And that's how we rationalize a denominator in the form, okay, root A plus root B or root A minus root B, okay? So you multiply top and bottom of the fraction by what we call the conjugate. So you flip the sign, okay, of the middle term, okay, and then that creates difference of two squares on the denominator, hence getting rid of the surd on the bottom of a fraction, hence why we call it rationalizing the denominator, okay? So it's getting rid of the surd or surds on the bottom of a fraction, okay? Remember, surd, just an unsimplified, it's radical, okay, so it's a square root, of a non-square number, so root 3, root 2, root 5, okay, root 6, okay, these are what we all call surds, okay? So it's the square root of non-square numbers, or non-square integers, I should say. Okay, so that's how we rationalize the denominator, okay? Thanks for watching. AMT over and out, okay? Happy Sunday, okay? I hope you're finding, the upload is obviously useful today. Okay, the plan today is just try to record as many videos as possible. Okay, today, and I'm going to be, hopefully, doing some more GCSE content, but the focus now is to try and cover some AS Pure Maths content, which is why I'm pumping out a lot more AS Pure Maths videos, okay? Thanks for watching.